Hey everyone, it's Lakes. I am just recovering from a cold, but I'm feeling really good today and I'm super excited to record a tutorial. I was just talking with my good friend Euphoria about Horizon Royale, which is a classic Vidyuu world. And in there, we had a feature that I thought would be really great to cover. And so what happens in there is when a player dies or when a player loads into the world, we need to determine where to put them, but the maps are randomly generated. And so because of this, you can't just place spawn points. And there's a lot of instances where you might want to do this. It's also just easier than potentially having to discover like a random spawn point. And so the way that we did it there is we went above the world, chose a random position above the grid, raycast down, found a position on the ground, and then up from that by about half a meter, we then fired raycasts at every player who was actively playing the game and counted the number of players that we had line of sight to. And then we chose the position out of 10 that had the least lines of sight. And so we're going to be looking at how to make that in Typescript today. I'll have the script available in the assets folder in the description. And we're also going to expand upon that original by choosing a position that is also closest to a wall. So in addition to just having the fewest lines of sight, it'll also say if there are multiple with 0 people in line of sight, let's choose the one that's closest to a wall so you have the most cover when you're teleported there. Okay, so we'll say closest to wall. I'm going to put down direction as a question mark. I'm not sure if we can, but having a direction could be something interesting to look at. But I got a little notepad over here to convey my thoughts and just kind of follow for today. So without further ado, let's go ahead and jump into Horizon Worlds. We're going to start by creating a new world, blank world, custom model import, and this is just going to be called player placement. We'll call this random player placement and press create. Now there are a lot of ways that you can do this. And raycast is one, but now that we have navmesh, you could use navmesh to determine a valid position to place a player, which is kind of exciting and awesome. And the first thing we're going to want to do with our little world here is we're just going to build this with the assumption that we're going to use the grid as the map that we want to spawn players to. And we're going to just place some objects there. I also want to remove the fog. So gizmos, go to the environment gizmo, and then we can turn the fog setting to 0. That's a little easier to see. We're going to move this box to 0, 0, 0, where I throw a lot of junk, but there we go. Next up, we're going to think. I'm like, there's multiple ways to approach this. So I want to take the easiest method first and then potentially expand upon that with additional ideas later. And so the first thing we're going to do is going to pull out some shapes just to create some sort of like hiding spots. We'll just use cubes for today. And we're going to place these on the grid. So we'll just go to 0, 0.5, 0. There we go. And now we're going to click F on keyboard to focus. We can now see this here. I'm actually going to move this to 0.5, 0.5, and theoretically I can scale this to roughly 1 meter by grabbing the scale tool and then eyeballing that down till it hits the edges. There we go. So that's roughly 1 meter. So that's nice. And then I need this to be about twice that in height. We'll move this to 1. And then if I grab that scale tool and use the green or the y-axis, we can scale that till it just touches the ground. That is now just the height of a player. We could even move that up just slightly more. So if I go to 1.5, when that touches the ground, that would be 3 meters. So we'll go to 3 meters high. Nice. Okay, so this is our first sort of like hideable pillar. And that's kind of cool. I can now move this around and kind of create our environment. And I'm just going to start by moving these across the grid and clicking Control-D, I can duplicate. And we're going to create a lot of these. And this is just for the sake of testing our code out. And Control-D, there we go. Control-D, there we are. Control-D, there we go. Let's keep moving outward. And then Control-D. And then if I really wanted to, I could even select multiple of these at a time. Hit Control-D, and scale those over here, slide them over like that, and then potentially move this one around so it doesn't look as uniform. There we go, nice. And then just fill in these little gaps around here and here. Control D and Control D. Very nice. So this is too small to really prevent a lot of line of sight. And so to make this look more like a real life environment, I'm going to grab the scale tool and just choose one scale. And for each of these, I'm going to stretch it along one of those scales just to give this some real dimension, make it feel like an actual map you might play on. There we go. That's looking really nice. Okay, and so what we're going to try to do is find locations that are not currently occupied. And this is going to be, I'm so excited. We're going to also use NPCs to be able to have fake players that we can raycast to. And that'll just be for testing in the real world. We don't actually need the fake players there. There we go. That looks good. So there's other little things that we can do now that we've done this, like sliding stuff around to try and like make this a little bit more balanced. But for the most part, I'm pretty happy with that. So if we could jump into preview mode, we can actually check this out, and we can see that this definitely can create a lot of hiding spots and places that would be good to place. And so ideally we want to place players like right here, not right here. So ideally we want to try to get them as close to a wall as possible. Okay, so with that started, the next thing that I wanted to implement here was a few NPCs, just so that we can use them as our test dummies. And so the first thing we're going to focus on is placing an NPC as close to a wall as possible. So we're going to grab an NPC, spawn that into the world. Now they behave a lot like a player, so we're just going to call this NPC. We're going to move it to 0, 1, 0, so right at the world spawn point. And they're not going to have any script attached. They just come in as a player, so it's all good there. And so then the next thing we want to do is create our first script. So I'm going to go ahead and click Create, and this is going to be called, I need a good name for this. I hadn't really come up with one yet. We need two scripts, one to engage with the actual tool. So we're going to call this teleport player underscore function. So this is where the functions for teleporting the player are going to be stored. We're going to need teleport player underscore data, which will store some data that we're going to use. Do we need that? Yeah, we do, because we need the raycast, which is going to also require us to have a teleport player entity, which will give us access to the raycast. And then we need a manager that does the actual player teleporting. And so we're just going to call this test player teleporting. We'll call this test. To mirror it, we're going to go test teleporting player. And this will be an entity. And enter. Okay, so we got quite a few scripts there. And they're not too crazy though, so no stress here. Going to click Open an External Editor. Get that VS Code open. Here it is. Going to snap that there. Looks good. Mostly fills the screen. And I can quickly switch back to Horizon, which I think is good. Okay, yes, I trust the authors. And data is going to be a data file. So we're just going to backspace all this. And then we're going to need to define what type of data we're storing here, which is, I'm going to zoom this in for you in case that helps somebody. We'll go ahead and hit allow. I wish there was a way to turn this off. There must be. Don't show again. I should have clicked that a long time ago. Okay, teleport player data. We need a constant. This is for the raycast. And so this is the ray. And this is of type raycast gizmo or undefined. And I meant, oh, it's supposed to be a let. Sorry, my bad. There we go. And then the next thing we do is we say constant, and then the name of this for our data file, I like to do it, call it teleport player underscore data equals JSON object, so a bag of stuff. And in that bag of stuff, we put our raycast. And now this gives us access to our raycast in all of our scripts. We only want to use this inside of our teleport player scripts, but anyway, that's fine. Now our teleport player function is going to be very similar to this. So I'm going to hit Control A, Control C, go into teleport player function, Control A, backspace, Control V. We don't need these top two, so I'm going to delete that. We're going to change this from teleport player data to teleport player func, and then deleting this line here, and we'll add functions in the future, hitting Control Save. So now that we've got our data file and our function file set up, we can go work on our entity. And our entity here is actually a component, so we're going to keep most of this. I do delete the HZ dots, so that's what I'm doing here. Backspace T, it's a personal preference, one that you are welcome to adopt or ignore. But anyway, so now that I've got my script set up, we're going to add a property to the properties panel. So that's props definition, clicking enter. Now going to create the array, which will be curly braces, type, colon, and then prop types dot entity, there we are, comma at the end of that, Shift Alt F. And then in pre-start, we're going to assign the value. So pre-start, we're going into the data file, which was called teleport player data. That's not there. I forgot to hit export on that, my bad. Export constant teleport player data, Control Save. I forgot to also do that here, interestingly enough. Export constant teleport player function. Okay, here we go. So now back over here, we can now type teleport player data, pressing enter. There we are. So now we've got our teleport player data. And if we hit the dot, we get the raycast that's inside of it. And we can now assign the raycast. So we say ray equals props dot ray dot as parentheses raycast gizmo. Oops. Raycast gizmo, there we are. And I like semicolons, so I put a semicolon on the end and Control S to save. You'll note that this question mark means that if this ray is not assigned on the properties panel, it will not throw an error, and we will basically have errors elsewhere in our script. So you gotta make sure to assign this. There's no reminder, so I just gotta make sure to fill out the properties panel. Okay, so our teleport player entity script is done. And now we can go to our teleport function and our test teleport player entity. We're going to need both of those. And the first function we want to create isn't going to be functional yet, but we're going to get it ready to go, which is going to be called teleport player, and then we're going to call this random, I want to call it random location. Yeah, random grid, no, random location, okay, and parentheses, curly braces. And now we have this function. It doesn't do anything yet, but we can now export it. There we go, random location. And we will, sorry, comma. Random location goes on 5, there we are. And so we're gonna export this function. And now in our test teleporting player entity, we can now teleport players. I'm going to delete these HC dots just like before. And backspace T, type, click enter. And we do need a pre-start as well, so I'll click pre-start again. You'll notice I don't like void, so I delete it. It's not required. So just another personal preference, Control Save. So like start is technically also void. I just prefer the way it looks without void. Okay. And so now that we've got this set up, in pre-start we can connect player enter world events. And so we're going to type player enter world, parentheses is received with a player parameter, player colon player, and then curly braces. And to connect this in pre-start, we're going to type connect code block event, parentheses from this dot entity, all components receive this code block event we're using, which is a code block events with an S, make sure to get the one below. And then dot, this is when player enters world, so I'll type player enter, and there's player enter world, clicking enter. And then if we hover over player enter world, you can see that it takes a player parameter. So we can type comma, and then inside of our parameter here, we can type in player, Then we're drawing an arrow function, curly braces, and then we're calling the local player interworld, clicking enter, that'll connect us to this .player interworld. Parentheses, we now need to pass the player parameter, so we type in player, and click enter. I like semicolons, so I add one there. I scroll to the end, add one there. I then hit Shift-Alt-F to reformat anything that was messy. I can collapse this using this button here to make it easier to see the whole line. Looks good. Cool, Control-Save. So now player interworld is called, and when the player enters the world for our test script, we want to teleport the player using this random location. Now it doesn't do anything yet, but we can get it all ready to go by typing teleport player functions dot random location parentheses semicolon Control-Save. Now we should pass the player parameter, so let's go ahead and do that now. Double click, Control-C, Control-V. Going over here, we need to add that parameter here as well, so player colon player, and now we're accepting that as a parameter, which fixes it over here so there's no errors anymore. Okay, so to teleport this player, we're going to start by using instant player motion. It's not ideal, but we'll address that later on. And so to turn on instant player motion, we need to go to our player settings. And under player settings, we can change custom player movement and turn that on, and then press save. That's going to allow us to teleport players. And so now that we've set this up, we have our player who will enter the world, and it's not going to do anything yet. So if I go back into VS Code, we can just console.log parentheses. Is there player.name.get? Is that the NPC name that I gave it? Control-Save. And so we'll console log that to see that this script is functional. We do need to attach some scripts to empty objects. So we're going to go ahead and create an empty object here. This first one is the teleport player manager. And we'll go ahead and attach that teleport player script. Here it is, teleport player. There we are. I like to move these to 0, 0, 0. We do need to attach a raycast. Let's not forget to do that. So we'll quickly pull out a gizmo, raycast gizmo. There we are, there we are. And this will be called the teleport player raycast. It will collide with players and objects, so both. I don't think it needs to be larger than 200, so I'll just leave the raycast distance at 200. I don't need an object tag. And then I'm going to also move this to 0, 0, 0. We can then go into our teleport player manager and reference the teleport player raycast. So just typing TE, there it is. Now I've referenced our raycast. We just need to make one more manager object. And so we'll click empty object, and this is the one that does the actual teleporting. And so this is just an example. You'd want to tie this into wherever your trigger is that players use to teleport into the game. But for now, just to demonstrate it's working, we're using the test teleport player entity script, which will use player interworld. So we've got our script attached. I'm going to then move this to 0, 0, 0, 0, 0, 0. There we are. Now with that set up, we're going to see on the console a NPC. There it is. It has been logged to the console. It's interesting, we got 2 logs of that to the console. Let's go ahead and hit stop. Clear. Do we always get that? No, that was just some sort of weird bringing the NPC in. Anyway, so we just get the one NPC logged to the console. Very nice. And with that log to the console, we now know that our script is working, and we just need to teleport the player to a random location. Let's start by just choosing a random location. That seems like a great starting point. And then we'll work on making this random location have all the properties that we want it to have. So the first thing we're going to do is to get rid of the console.log. And now we want to determine a random position. And we're going to create a function for this. So we'll type function, and then we'll say generate random position, parentheses. It's going to return a vector 3. And we want to provide some properties to this, like the, I'm going to call this radius, even though it's not exactly a radius. It's more like width and depth, but we'll just call it radius. So radius is going to be a number. We're then going to want to know the y value. Maybe we'll call this y radius in case we decide that we want to give that some variance in the future. So y radius is a number. And we want to know the center, like the starting position. So we'll call this center, which is a vec3. Okay. So now that we have these three values, we can start to determine our randomly generated vector 3. So the center is the position that we want to start from. Then we have a radius, which will represent the x and z depths. And then the y radius, which will represent the y height up and down. Now, to create this value, we're going to start by creating a value which we'll call the constant random position equals center dot clone. So we're going to clone the center position. And this is going to allow us to adjust the properties one at a time. So we can now type random position dot, and then we're going to go to the y value, and then say plus equals. So we're going to add to the y value, and we're going to take the y radius to determine if we're going up or down. And so if we take y radius multiplied by 2, we now have the diameter, which is a terrible way to describe this, but the amount that we go negative or positive. So this creates the amount of variance. We then need to multiply that by a number that ranges from negative 0.5 to positive 0.5. And we can do that by using math.random, which returns a number between 0 and 1. And then saying math.random minus 0.5. And then we'll do another multiplication after that. And then we're going to put this inside of parentheses. So the first thing we've done is said math.random minus 0.5 is going to return a number between negative 0.5 and positive 0.5. We then multiply that by the y radius times 2. It might be even clearer if we say multiply by 2 and then multiply by y radius. So you can imagine that this is now saying, okay, we've generated a number between negative 0.5 and positive 0.5. Let's then change it to be negative 1 to positive 1 by multiplying it by 2. And then we multiply that by the y radius, just a little easier to read. And now that's going to generate a random y value. Now if you type in a radius of 0, well, let's imagine plugging in a 0. Math.random minus 0.5 times 2 times 0 returns 0, so it doesn't change the y position, so it doesn't do anything, just does the extra work, but that's okay. Next up, maybe we'll add an if statement here that says if y radius is valid, then do this. So we don't do anything unless y radius is defined, and then we say it's either a number or undefined. And so you could pass in an undefined value to declare here that you don't want it to be. Also noting that this if statement negates a 0. So if you type in a 0 doesn't do anything either. So it actually has to be a value that's defined, so that works out. Okay, next we're going to work on the regular radius. And so this one really needs to be defined. And so to determine this one, it's very much the same. So let's just copy paste this and see what we need to change. Command C, Command V. We're going to start with the x value. So x will be math.random minus 0.5 times 2, just like before, but instead of using y radius, we use regular radius. And then we duplicate that, Control C, Control V, and do that for the z value. X and z are now updated, y is updated, and we've now created our vector. And we can now return that by typing return random position. There we go. Okay, so that is our generate random position. We can now move the player to that random position by typing player.position.set parentheses, and then we call, we're going to actually do this the better way. And so we're going to copy this line, Control C, Control V. And so we're saying constant random position equals, and then we're deleting this and typing generate random position, parentheses, or parentheses. We then need to provide values. Our center position is going to be new vec3 parentheses 0, comma 25, comma 0. Our radius, you know what, we're going to do this a little bit differently. Control X. We're going to our teleport data file, because this is where all the data should be stored. And let's create variables here, like center. Center equals that. Perfect. And we need to import vec3, so backspace 3, click enter. And so the center position is going to start at 25. I might change that to 50 so it's well above the world. And then we need to create a radius, which is going to be the grid size, which is 32 is the radius. So the grid is 64 by 64. And then we need the y radius, which is 0. We're not actually having a y radius. So there we go, control save. And now those values can be updated from this file for your world. So if your world is not centered at 0, 0, you can move this center. And if your world is higher, you can move this up. If your radius is larger, you can change that or decrease it if you need to. And now over here, we can pass those parameters by typing in teleport player data dot center, teleport player data dot radius, and teleport player data dot y radius. There we go. And I accidentally added an M there. Perfect. Okay, so now we've generated a random position, and now we can set the player's position to that random position. And like that, we've now teleported the player to a random position on the map. Now this isn't a great position on the map, it's just a random one. And it's above the world, so it's not placed on the map yet. But this is a great starting point. So let's go ahead and see this player as they spawn into the world get teleported. I'm worried about the time it takes to load into the world, causing this to not move the player, but we'll see in a moment. Hitting play. Issue. Player has no current position, probably, or something like that. Yes, this is happening too soon on world start. So if the world was already running or the player was already in the world, this wouldn't be an issue. But because the world is just starting, we need to delay this. So we'll type async dot set timeout, parentheses, parentheses, we're creating an arrow function, curly braces, comma, the delay is going to be 1500 milliseconds, so that's 1.5 seconds. And I like underscores here, so I'll add that underscore, clicking enter. This is the code that we're going to run after the delay, so I'll move that up and control save. And now we've got a 1.5 second delay. We'll give that a moment to reload. Clear. Clear and play. There we go. Player loaded into the world. Applied batch setters. Okay, we have the same error. Interesting. I'm not being able to read this, which is weird. Oh, here it is. Exception encountered running bridge method. Apply batch setters. Player has no current locomotion controller. Let me see if I jump into the world. Yeah, okay, so it works for real players. It doesn't seem to work for NPCs. That is strange, isn't it? That is very strange. I would have expected that would work just fine for NPCs. Okay, well, at least it works for us. So, that is really quite interesting, isn't it? So that is leading us to, I'm just thinking, darn these NPCs. I don't know if we need to delay then. So let's remove the delay and just have it instant motion when I walk into the world. Control save. Wait for that to load in. And clear. Go ahead and hit play. That doesn't work on the NPC, but that's okay. I jump into the world and it works. Ooh, it almost works. But it then teleports me to the spawn point. So we do need the delay for sure, but I don't think it needs to be as long. Control Z. Let's change it to just 500 milliseconds, so half a second. There we go. Give that a moment to compile. Go ahead and hit play, jump into preview mode. Okay, that works. So we just need the half-second delay. Okay, so now that we got that started, we now want to place players, and I also want to differentiate between our NPCs and our players. And so we're going to add a little if statement here, and I've got a way to determine if a player is an NPC. It is if parentheses, and we're going to need access to some stuff that we don't have access to yet. And then let's move this over here and press Alt arrow up. There we go. And what we're trying to check is if, let's see, get, it's component, no, it's avatar. Yeah, we need to import this API. So we're going to go back to our script, gear settings, go to API. We're going to go ahead and turn on the avatar AI agent API, press apply. This will give us access to determine whether or not a player entering the world is an avatar AI agent. And so now we can type in, let's see, you type avatar AI agent dot get gizmo from player, parentheses player, and this will return either the entity that the player was spawned by or undefined if they're a real player. So then we can say if triple equals undefined. So if the player doesn't have a gizmo, then we know it's a real player and we'll teleport the player. So go ahead and hit Control Save, and that will remove the error that was happening on world start. And we'll have to manually place these avatars around, but that's okay. Go ahead and hit play. Hit clear, no errors, jump into preview mode. Works nicely. Cool, good stuff. Okay, so now that we've got our first avatar on the map, we do need to create a few more of these. So let's go ahead and slide them around. Where do we have our, here's our NPC. We're gonna slide this guy over here, Control D, slide him over here, Control D, slide over here. So we're just gonna have 4 of these on the map. And it doesn't matter where they're at, but we're trying to make it so that we can determine a position that has no line of sight to any of these players. So it's gonna try to find a position that hides you, which is ideal. Okay. But let's get back to placing the player on the map first. I need to write down just a thought, which is that we need a list of active players in data. I'm so sorry. I'm still a little stuffed up from my cold the last few days. Okay, so now our teleport player function has determined, I'm going to zoom this out a little bit so we can see the whole thing. It has determined a random position to teleport the player to. It's above the map though, so let's first ground this position. And so we're going to say constant grounded position equals, and then we're going to take the random position and we need to move it to the ground. Random position dot clone. This is not what I want to do. And then this is not what I want to do. We're just going to leave that there for now, and we're going to get back to what we actually need to do, which is we need to fire ray cast. So we're going to say constant ray hit equals, and then we go to the teleport player data file .ray.raycast, and then parentheses, and we're going to raycast from the random position. We're going to raycast downwards, so vec3.down is 0, -1, 0, so that's going to raycast us down. And then we want to provide no other options. I don't think we need options. Yeah, we'll be fine. And then semicolon at the end. And if we hover over ray hit, we can see that this will be a raycast hit, a null, or an undefined. And so we now need to utilize this ray hit to determine our position. And so we can say grounded position equals ray hit dot hit point, and then this is now potentially undefined, but let's make sure that it is defined. So not ideal, but if for some reason this is undefined, what do we want to do? We should come back to that potentially later. Okay, so we've got our grounded position. We now need to increase the y value by 1 meter. So we say grounded position dot y plus equals 1, so that it's off the ground. Now this is upset because it might be undefined, so we're going to need to use an if statement. So we'll say if. This is why I wanted to do this. So we're just going to say rayHit.hitPoint is undefined. Then we're going to type in question mark, random position. So it uses the original position. This is not ideal. The only reason this should come out undefined is if you have your raycast set to a distance that isn't valid. So in our case, it's 200 meters. So if it was like more than 200 meters down, or if there was nothing there, like it's firing above nothingness, so it fires, which again is the same problem. And then the second problem would be like it's not defined on the properties panel. Yeah, so this should never happen, but if it does happen, it'll just teleport the player up in the sky, and that's better than nothing. So we'll add 1 to that position, which should determine the position right above the ground. And then we're going to move the player to that position, which is going to be a lot better than our current situation. So let's go ahead and try that out. And now we won't be falling from the sky, we'll now be falling from the ground. And we're getting closer to what we actually want to have happen. So let's go ahead and hit play, jump into, that was interesting. Stop, play. Okay, there are no errors, it was just weird backlog, I guess. We'll jump into preview mode. That wasn't supposed to happen. That's interesting. Why did that happen? We might need to do some research into why that happens. So let's go to our teleport player manager. The raycast is defined. The raycast is set to 200. It's set to hit with both. Might need to do some research. Why is it teleporting us from above? Let's see. Oh, because I'm passing in the random position, not the grounded position. Right here on player.position.set. That was the problem. Control save. Okay, cool. I was like, what's wrong? Easy mistake. Okay, now that that's done, clear, play, jump into preview mode. There we go. All right, so it did determine a position. It's not next to a wall. It's not in line of sight of anything, so that, oh, actually, maybe. But it's not bad. It's not bad at all. So stop, play, jump into preview mode. And here's another one, totally within line of sight of another one, or almost 2 players. And so, not ideal. So now what we need to start doing is reducing the number of sight lines to players. So to do that, I'm going to do the same thing we did in Horizon Royale, which is fire 10 positions. So we're going to choose 10 random positions. We're then going to fire raycast from those positions to determine which player which position has the least number of players with line of sight. And so we're going to, let's see. Basically, this is going to determine a random location, is what this does. And so let's create another function down here. Function. And this is going to be called get random grounded position. Okay, parentheses. This returns a vec3, curly braces, and then we're going to go ahead and cut all of this. Control X, Control V, and I want to change this to get random position as well. So we're just going to change the name to match. Backspace, caps off, cap T, Control C, Control V. So get random grounded position, which returns a vec3. So we need to return the grounded position here. So we'll type return grounded position. All right, Control save. And then here we have to set that. So I'm going to copy this line of code here, Control C, Control V, and then we're going to replace this with get random grounded position. There we go. And now that we've got that set up, we now want to create 10 of these. And so we're then going to say, what's the easiest way to create 10? I think it's a for loop, right? So we'd say or maybe even a while loop. I don't know if it matters. Both should do the trick. What am I? I would say I'm actually. Yeah, we'll just use a while loop. I feel like it's easier. So we need to create an array of grounded positions, and so we're going to Control-C, Control-V this, call this grounded positions, colon, which will be a vector3 array, and this will equal an empty array, backspace, empty array. And so now we've got this grounded positions array, and we want to say while the length, or so we say grounded positions dot length is less than 10. So once it equals 10, it'll stop running this loop. We're then going to say grounded positions dot push to add an item to the list, and we're going to add this get random position. Control X, Control V. I like semicolons, so I put one on the end to delete this line of code here. There we go. And so now we've got an array of 10 random grounded positions, and we need to determine which of those 10 positions is the best. And so as much as I like a vector3 array, I'd like to create a new custom type to determine information about each of these positions. And so I think the easiest way to do this is going to be to create a custom type. I like to put my types in separate files. But this one's really just used right here, like really just used right here. So I might do something slightly different. So we'll say that grounded positions is an array of things. So backspace, curly braces, and then inside the curly braces, we're going to have the position, which will be a vec3. We're going to have the player count, which will be a number, and we're going to have the closest wall distance, which will also be a number. Yeah. Okie doke. So this is a bag of things that isn't declared. Like we could have made a type for this somewhere, just like vector3 is a type or number is a type. But instead, we're just going to have it here because it's only used right here. And then right here where we're creating this inside the while loop, we're going to put curly braces around this. We're going to then type in POS to determine the position. We then need to provide 2 additional values. Player count will start as 0, and closest distance is going to start as 0 as well, although I might change that to 99 later. We'll see. Okay. So now that we've determined all of these positions, we can then go through those positions and count the number of players. And so what we want to do is say, let's see, excuse me, grounded positions dot for each, parentheses, parentheses. Then we're going to create an arrow function here, curly braces, semicolon at the end, click enter. And now for each grounded position, we're going to run this function. So the values inside of a grounded position, there's a payload, and that payload has all those values. So we'll just call it payload, but you can hover over it to see that it contains a position, a player count, closest wall distance. Now what we need to do is try to figure out the closest wall is kind of difficult. So I'm going to just write that down as a future. We're not worried about that right now. So determine closest wall, fire raycast in 8 separate directions, question mark. Okay, that makes sense. And then the next thing I want to do is, yeah, 8 directions would be like pretty good. I feel like that'll do pretty well. You can't see it, just so you can. I literally was like, 8 directions, 45 degree, that should work. So anyway, but you know, like, it's the process. So now that we've got our for each loop here, oh, I just realized you can still see me. Let's go, boop, boop, there we go. So now that we've determined, we've got this for each loop, we can now count the number of players. And so this is another great place to create another function. And so we're using get random grounded positions here, but now this is happening afterwards. Get random grounded positions uses get random positions. So I'm going to put this below this, and I'm going to create a little extra space. Maybe not. Sometimes it's hard to like organize functions when there's so many using all of these different things. But anyway, this function is going to get us the value of the number of players with line of sight. So we're going to say ground positions dot for each payload. We want to know the player count. So we're going to say function get, or we'll call this count number of players with line of sight. There we go. Count number of players with line of sight. And this will return a number and curly braces. And what we need to do is take in a vector 3. So vec3, which we're going to call position colon of type vec3. There we go. And then from that, we're going to return a number. So for now, I'm just going to type return 0. We need to come back and fix this in a little bit. There's quite a bit that needs to be done to make this work. But let's first just get it implemented up here in our for each loop. And to do that, we type payload dot player count equals count number of players with line of sight, parentheses, payload dot position. And that is going to get us the number of players. And that's a pretty good goal. I think there's one thing we should do here, which is determine the number of players. So I'm going to create a comment here to remind me. It's going to say create array to track all locations with 0 players and to track closest distance, and also a variable to determine lowest number of players in instances where there is players at all locations. Okay, so that might not make a ton of sense, but we'll come back to it in just a moment. Okay, so next thing we need to do is know about all the players who are playing the game. We should try to fix this code here while we can. So just to make sure this is functional, we're just going to type vec3.0, put a red dot next to it to remind me to come back and fix that. And we're now going to go to our teleport player data, and we need to know all the players who are currently active. So we'll call this players. And players is an array of players. And we just type square brackets, but that's not really what you want to do. So instead, we're going to come up here and type constant players colon is a player array, which equals an empty array. We can then type players comma, which will then link it to this constant. And now we have an array of players. And so on our teleport player entity, this needs to track the players in our world. So we're going to copy some code from pre-start over here, Command-C, and then we're going to maybe only copy this singular line, Control-C, and click Enter, arrow, Control-V. There we go. We need to import code block events, and we don't have player enter world, so let's copy that line over here as well, Control-C. All right. Nice, Shift-Alt-F. We do need player exit world. We don't care about avatar AI agents, so I can delete this if statement. Backspace. We don't know about a player yet, so we need to backspace the R, retype R, click Enter. And we also want player exit world. So Control-C, Enter, Control-V, change this to exit. Exit. There we are. And then we can duplicate this, Control-C, Control-V, change this to exit world, and change this one to exit world. There we go. And now we've linked player enter world and player exit world. And on player enter world, we can add to the array. So we call the teleport player data file dot players and say dot push, and then parentheses player. Now, if for some reason this player is already in this list, we don't want to add them twice. So we're going to type if parentheses exclamation point does not include is what we're going to be saying. And then we type teleport player data dot players. So we're saying dot includes parentheses player. So if this array does not include the player, we're then going to add the player to the array using .push. And then when they exit the world, we want to remove them from the array, which we can use the array utils that hopefully you've already got access to. If you don't, it is available for download in the video description from the assets folder under the utilities file. I should have this inside of my downloads folder. Let's see, array utils, utility component. I might go grab it from a different world. So if you have scripts in your other worlds, what you can do is reveal and finder, and that's going to, reveal and explore. We're then going to hit the 3 dots, hit horizon worlds, and then find a world that we know has it. Like I know for certain it's going to be in the latest version of Power Wash. So we'll go into Power Wash, scripts, go to the bottom where utilities are, grab utility array. There it is, Control C, hit the back arrow, and here we are, Control V. Now I've got my array utility file here. And this just makes it a little bit easier. If you really need to write this out yourself, remove item from array is this. It's just a lot of code to write every single time you need to remove an item from an array, which is why I have this function. So I encourage you to download this if you haven't already. So now we call array utils dot remove item from array. Parentheses, the array is the teleport player data file dot players array. The item is the player exiting the world, and this will do nothing if the player isn't in the array, so it doesn't need any sort of like checks, so it's just good to go. And that is our player enter and exit world to track the number of players. Whew. And so we can now head back to our teleport player function and use that to calculate the number of players. So let's go down here to count number of players with line of sight. And now we're going to say teleport player data dot, and we're going to go to players. And theoretically, we don't need to calculate this for the player that we are teleporting. We're just going to ignore that fact for now. Definitely would be a good improvement in the future. We're going to type for each. So players dot for each, parentheses, parentheses. Player is the parameter that we have in the array. Arrow function, curly braces, I like semicolons, clicking enter. Now for each player, we're going to calculate if they are with line of sight. We need to count that, so we're going to create a number. So we'll type constant, or excuse me, this is a let count equals 0. And then in here, we can say constant ray hit equals, and then we're going to go to teleport data dot raycast parentheses from the position. We are going to raycast. The direction is got to be towards the player, so we can do player dot position dot get. That's going to determine the position of the player, and then with that player's position determined, we can then subtract from it dot subtract the position that we're firing from. So subtract parentheses position. That will return the direction. I don't know if we need to normalize it or not, so I'm just going to do it anyway. Dot normalize, and then parentheses, which makes it turns it into a direction vector. Like this is a distance vector, now it's a direction vector. Might not have been necessary though. And now that that is done, we can now determine if we have line of sight to that player. So we say if parentheses ray hit dot target type triple equals target raycast target type dot player. If that is the case, we know that we've hit a player in that direction. Even if there's 3 players in a line in that direction, we've hit a player. So like that's line of sight, right? So we'll then say count plus plus, and that should do the trick. So now we return the count here at the bottom, and now we have determined the number of players that are in line of sight of that position. So with that being done up here, We have determined the player count. We're not going to worry about the closest wall yet. That's definitely like goal for the future. For now, let's just create an array of all of the locations that have 0 players. And so we want to start by saying, we'll say let minimum players equal, and then we'll go to teleport player data dot players dot length, and then that gives us a value to fight for. And then we can say let current position equal vec3 dot 0. Well, let's actually use one of the positions. So we say grounded positions index 0, so item 0 dot position dot clone. So we have a current position determined. Maybe we won't clone it, just in case we need that for something later. Cloning would make it a completely new value, so it would not be equal to. So I'm just like, it's okay. We're not going to be manipulating the current position. So we set let current position equal grounded positions 0. We've now got minimum players as the length. So neither of these are what we really want. We then want an array of all of the 0 positions. So we're going to say constant 0 positions. We'll call this 0 player positions. And this is going to be an array of 2 types of data. So we need the position, which is a vec3, and we need the distance, which is a number, which we haven't set up yet, but we'll get to in the future. And then this will be an array of that type of data, which will start as an empty array. And so 0 player positions are the ones that we want to, if we have multiple of, compare against each other. Otherwise, we're just going to use current position. So what we can then do is say, we've determined the player count. We can then say if, parentheses, player count, so that's payload dot player count, triple equals 0, meaning we have one of our 0'd positions. We can then go to the 0 player positions and dot push that value. So curly braces, the position is, we'll type position colon payload dot position. And the closest wall distance is going to be, what do we call that? Distance colon payload dot closest wall distance. And we want to do this after we've done that. So let's go Control Z, move this up. So Alt arrow up to move that up, and then moving that up as well to get some space. So we're going to determine the player count. We're going to determine the closest distance in the future. We then check if the count equals 0, then we add it to the 0 player positions. What we also want to do before we determine the closest wall is just see if this is a better position than previously. And so we can say if, parentheses, the payload dot player count is less than minimum players, we can then say, oh, this position is better than the previous position. So let's say minimum players equals payload dot player count. So we've updated that value. And we can update the current position to be equal to payload dot position. So now that we've done this, we'll determine the best position, even in a case where there are tons of players playing and there are no positions with no line of sight. We'll find out which one is the best at least. So it has the fewest lines of sight to players. So then we'll do the walls, then we'll do adding to that array. And after all that's done, we can now say if, parentheses, and we're going to want to break this up at some point, I think. But anyway, actually, let's break it up right now. Okay, let's Control-Shift-Z. The goal of this whole set of code here is to determine the best position. Control, and we've actually done this line of code. That's all done now. But yeah, this is all to determine the best position to go to. So Control X. And so right here, first thing we're going to write up is function determine, or so this will be a get. So get best location. And then we'll say parentheses, parentheses, curly braces, and then Control V, and then we want this to return a vector 3. And I also want to provide a number here, which is the positions to try, which will be a number. And so rather than using this kind of like magic number 10, we're just going to copy this here, paste it here. And so in the future, if we wanted to change this to be like, let's try 20 locations because there's less players online, or let's try 5 locations because there's a lot of players online, that could be a thing. Or you could do the inverse of that if this isn't too heavy on the world. Now we do need to return a vector 3. So down here, this is where we were going with this, which is to say if, parentheses, the the 0 player positions dot length is greater than 1, meaning there are more than 1 positions, we're going to have to determine which is the best. Else, we can just return the current position. So we'll say return current position. And then if it is, we need to say determine best position, right? That's something to do. And then for now, we're just going to say return 0 player positions index 0 dot position. So for now, we're just getting item 0 from the array and returning that. But in the future, we need to determine what is actually the best position. And so now that that's actually being returned, there's a few things we need to do in this later, but we can now actually call that and say, set the player's position to get best location, parentheses, we'll type in the number 10. And now this function looks really simple. Function, random location, player.position.set get best location of 10. And like, if you need to dive in deeper, you can dive in deeper and read all about it, which is kind of what I love about breaking these functions into smaller and smaller pieces, is you can just go as deep as you need to and focus on the areas that need to be focused on. So go ahead and hit Control Save. This does function. It doesn't take into account the best of the zeroed locations, but it is determining a zeroed location. So if we go into our, I don't think we need to do anything actually. This is just going to work. So we can just hit clear. And now when I load into the world, my line of sight should be none. So we'll hit play, jump into preview mode. And from right here, well, from his perspective, I can't see that player. And I can't see that player. So this is a good position. If we go into first person mode, if we change this to say force first person, we'll be able to see that a little bit better. So stop, play, jump into preview mode, and here we are. As we can see, no lines of sight. Now I walk forward, immediately see someone, I could go and duck and cover and hide. But the thing that we really want is not to put you out in the open like this. We want to put you next to a wall. So that's the next thing we want to do, is compare all of those zeroed positions to see which one is closest to a wall. Okay. So let's head back to the code. And let's see, so far so good. We now need to determine the closest wall, which we're going to do by firing raycasts in 8 separate directions. And then let's start here by going backwards. We're going to imagine that we've already done this raycasting in 8 directions and we have the distance. Let's now just write the code down here because this is easier. So what we need to do is find the let closest distance equal this value right here, Control X, Control V, and then instead of this being position, this is going to be the distance. And so we're just going to start with item 0 in the array, and then we can compare from that point forward. And then current position is we're going to continue using current position. In fact, we can actually move this return current position below this if, and then we're not returning inside of this, we're only returning at the end, and instead we're going to say current position is not a let, this is just an equals, so we say current position equals 0 player positions, item 0 dot position. All right, so this is already off to a great start, but now we're going to go through every position and determine which one is the closest. And so we say 0 player positions dot for each parentheses payload. Oops, excuse me, try that again. Payload. And then just like before, we can hover over that to see what the properties are, like what's included in that payload. And we can hover over that right now just to see it. There it is. We have the position at the distance. And we want to say if parentheses the payload dot distance is less than the closest distance, then we want to update the closest distance to be equal to payload dot distance, and the current position should be also updated to payload dot position. And this will go through each one to determine which is the closest position. Fantastic. This now works, and this part of the code is done. Now we need to just actually determine what is the closest distance. I would potentially recommend breaking this into multiple functions as well to make this whole thing a lot easier to read, but for now it's okay. Okay, so determine closest wall. We want to fire a raycast in 8 separate directions, so what I want to do in the data file is create something a little janky, but it'll do the trick, which is to create a thing called check directions. Now check directions is going to be an array, and I should probably really clearly say what this array is. I think if I type this out, it might do it. So let's try this. I'm going to copy this value here, Control-C, Control-V, and then put a comma. And if I hover over this, it says it's a vector3 array. Perfect. That's what I wanted it to be. So now we can determine some vectors, and these are going to be direction vectors like 0 or 1, 0, 0, which would be x, which is like left. And then we're going to Control-C, Control-V. We do -1, that's like right. And then we'll do Control-C, Control-V. And then we do 0 here. And then we do 1 here, that's like forward. So that's forward by 1, Control-C, Control-V. -1 is back. And now we need to do the left, like forward, left, rightward. And so I'm just manually creating this. There's probably a better way to do this, like with some math, but this isn't too bad. So we'll go ahead and hit Control-C, Control-V. And now to create a direction that points towards, like, I don't know. I'm trying to say this, but the point is you're just going to type 0.707. I believe that's the number. And then this one will also be 0.707. And then we need the 4 variations of this. Let me double check that that's correct. We'll use Google Chrome to verify our work. And so we'll say, I don't know what that is. I'm going to have to read that later. 45-degree angle vector values. Am I right? 707, approximately .707. Okay, perfect. That's what I thought. Feeling pretty good. Close out of that. Okay, so we got .707, Control-C, Control-V, VV. There's our 4 values. And so the first one is pointing, I guess we'll just imagine it's pointing northwest. Then we do negative. That's like the opposite direction, so that's southeast. And then we do negative on the left side, and then we do negative on the right side. And that should determine all 8 locations on a 45-degree circle. Okay. So these are the directions that we want to fire our raycast to check the distance, to find the closest distance to the position, to see if there's any walls nearby. Like I said, this is a little jank, but it should do the trick. If you have a better way of doing this, please leave a comment in the YouTube comments or in the Discord. I would love to hear what's a better way of doing that, because I've done that a few times and I'm like, man, there's got to be a better way. But it's okay. Determine closest wall, fire raycast in 8 separate directions. So Now what we need to do is say teleport player data dot check directions dot for each parenthesis, this is a direction, so I'll type dir for direction, arrow function, curly braces, just like before. We've done this quite a bit now. And now we need to fire a raycast in each of those directions. And so we say constant ray hit. Make sure there's no ray hits near this, just in case. I think we don't have any. Looks like we're in the clear. Constant ray hit equals teleport player data dot raycast parentheses from the position, which is payload dot position, and the direction is the direction dir, and that's it. That's all we have to do. And there's a little bit more to write here at the end, but I really want to check to make sure I'm not using this raycast anywhere else. It doesn't look like it. It looks like wherever we're using ray hit, it's in some other, like it's in one of these down here. So we're good, we're safe. Just trying to make sure we're safe since we've been using this variable a lot. Okay, now if we type if parentheses ray hit, this is going to verify that there's data in the ray hit. We can then say if parentheses payload dot closest wall distance, if that wall distance is higher than ray hit dot distance, then we know that we've determined a wall that's closer, and we can type payload dot closest wall distance will then equal the ray hit dot distance, and we're done. Like that, it's going to go through all 8 locations. It's going to determine which of the wall is the closest. Our code down here determines which one of those to use based off that information, and voila. So theoretically, when we play this, it's going to teleport us to a wall that's nice and tight and close, so we're not afraid of being shot at immediately or whatever the game is. Jumping into preview mode. Here you go. Look at that. Right next to a wall. But we have line of sight. That's strange. That is very strange. Like, I have line of sight to 2 players. What are the chances? I mean, it is possible that all of them were worse locations, but it should have, curious. I'm very curious about that. Let's hit play, jump into preview mode. Does that happen over and over again? This one doesn't have, it's not near a wall, but there is no line of sight, so I am very happy with that. Interesting. Stop, play again, jump into preview mode. Okay, once again, not very close to a wall, but we don't have line of sight. So weird fluke in the beginning. I'm not sure what happened there. Let's increase the number of places we're checking. Let's go to something ridiculous like 50 position checks and see if we get closer to a wall. I'm worried that this might break because that's a lot of things to do. But I guess we'll find out. Typescript is pretty powerful. I've done quite a bit. So if we need to, there are ways to make it work. It's a little further out of the scope for this video than I'd like it to be. Ooh, that is, something's wrong. I would like to say something must be wrong. It feels like it's choosing the position that's furthest away. Like, that would be my guess. Like, look how far away we are on this map. I mean, come on, right? I could do some console logs to see what's actually happening behind the scenes, but I think if we just read, I'm going to change this back to 10. If we just read through the script, we're probably going to find where the error is. And so we're going through best location. We say player count is less, check directions, dot for each direction. Now we really only need to do this, well, yeah, we really only need to do this checking direction if the player count equals 0. So I'm going to move this into this if statement here, Shift-Alt-F, because we really don't care about the player's distance if there are people in line of sight, so this is good. Now, checking through this though, we're saying closest wall distance is greater than ray hit dot distance. That does make sense. I want to reverse this though, Control X. So we say ray hit distance is less than payload dot closest wall distance. Now that's the exact same thing, it's easier to read. So we're now saying, okay, if ray hit is valid and ray hit dot distance is less than, oh, is it possible that because we set the default value to not 0, we're having issues because of that? Let's set this to 999, control save. Could that possibly be why? Interesting. Interesting. I'm not sure. We'll see right now. We'll find out. Okay, play. Jump into preview mode. I kind of have line of sight with that guy. Ooh, and definitely with that guy. What's going on with that? First time I load in, that seems to be happening. Very strange. Second time though, no problems. We are still at a distance. Jump into preview mode, could be a fluke. No, we're still seeing line of sight. This has me very going, what? Let's see. I know this player count could be set to something like 99 as well. Minimum players equals players.length. Current position equals ground positions 0. 0 player positions. If 0 player positions dot length is greater than 1. Because theoretically, if there is only one item, it was set up here when it was determined to be less. It says player count is less than minimum players, then we update minimum players and we update current position. That all seems right. If payload.player count triple equals 0, then I see. Wait, no, that's not right, because this is doing the player count right here. No, count number of players with line of sight. Player count triple equals 0. Could it potentially be not hitting the player somehow? Let's console log this right now. Console.log parentheses payload.player count. Because these NPCs could have more things going weird with them than I realize. So let's see if we're getting any player counts greater than 0. I assume we are. Hit play, jump into preview mode. Oh yeah, there's a bunch of numbers there. Totally what I would expect. 1, 0, 2, 1, 0, 3, 1, 0. So we have 1, 2, 3 zeros. So this appears to be working. That time it did work too. Let's hit play, jump into preview mode. Line of sight, don't see anyone in line of sight. Numbers, maybe it's just a really bad luck. Like this map does have a lot of sight lines to players, so maybe we were just really just getting bad luck on spawning next to players. And now it's not happening. Okay, it might have just been bad luck. I'm okay with that. It's like now that you're watching me, it's not going to misbehave since we're watching the... And we're next to a wall this time. Interesting. Next to a wall this time too. Interesting. Okay, so I feel very good about the number of players coming through. Seems very, very accurate. So I'm not worried about this. What I am worried about is the closest wall distance. So actually Control Z, Control X, and then we'll paste that up here. So when we're going through the wall distance, anytime that we update wall distance, I want to do payload closest wall distance and just update that on the console. So we should get a lot of distance logs. And then we'll go ahead and hit clear, clear, and play. Jump into preview mode. Ooh, that's not as many as I would have expected. We only had 3. Interesting. So there does feel like maybe something going wrong there. Maybe, maybe not. So it did definitely choose one that's really close. We're only 1 meter away. That is correct. Jumping into preview mode. Our next no console logs, and we got 2 lines of sight. Very interesting. Oh, that's because it only logs. Okay, so I think that is proof of what I was suggesting, is that because it's only doing 10 and there's so many sight lines on this map, it is just going to happen where you have lines of sight to people because of random chance. So it only does the position distancing thing. And in this case, we were 3 meters away from that one. Yeah, this actually all makes sense. So, as far as I can tell, we're not breaking anything. We're at 0.63. Yeah, we're right next to this. That looks good. So far so good. This is definitely functional. The biggest thing that I would change is updating the number of times. And so I want to start by going to 100 and just press Control Save. So we're going to compare 100 different locations. I'm very curious how like intense this would be, especially if you got a lot of players doing this a lot. Like if 5 players die at the same time, or 10, or more realistically, like the game starts and 10 players are teleported in at the same time. Jump into preview mode. Okay. I mean, that's as close as you can get to a wall with no lines of sight. That's pretty good. Nice. I like that a lot. Jump into preview mode. I do want to try and break it. So far, so good. There is one really important thing we still need to do. So we're really going for breaking here. We've done 100. Let's do 1,000. Like, if it's still functioning with 1,000, I don't think I'm worried. But I kind of feel like 1,000 is going to break it. Clear, play, preview mode. Really? No problems? You did all that math without any issue? Oh, there it is. Now that's more like what I would expect. So that time it ran over execution count. Or no, it says scripts were re-executed. That's weird. Clear, stop, play, jump into preview mode. Still working. Weird that we're still seeing somebody from this position. Did it really go through 1,000 locations and still not find a good one? I mean, that is how random numbers work. Could just be possible, I guess. So maybe this map is just bad. Like, it's quite possible the map plus the placement of the NPCs is just really bad. That looks like a line of sight, but it might have hit this wall or that wall out there when firing. Yeah, it might have like been at an angle like that. That would make sense. Ooh, hello. Yeah, anyway, as far as I'm concerned, this doesn't seem like it's going to break under pressure. So I would do 50 or 100. I'm going to set the default to 50 to be on the safe side, but if you came in here and changed that to 100, you're probably okay. Because that was, for whatever reason, not breaking at 1,000. So pretty solid, pretty solid. I was like, this has got to be super intense, but apparently it's not. Okay, so let me run through my to-do list here. I'll give you a visual on my brain function. Hello. Brain function. So PvP player placement. Raycast down, then at the players. We've done that. Count, 10x, choose the best position. We've done that. Share the script. We're going to do that soon. Start with player motion. We did do that, but we need to use spawn points. So that's the next big to-do item, because spawn points do the fade to black thing, but they're a little more complicated to use. So that's why we're holding off on that. Prefer positions close to, we did that. Nice. Closest to wall, we did that. Direction, we did that. List of active players, we did that. Okay, so the only thing left to do is spawn points. And like I said, this one's a little complicated. Okay. We need a spawn point for every player. They each need to have their own spawn point. Kind of difficult, but we're going to make it happen. So we're going to need a new script. And so we're going to create script. This is going to be called teleport player underscore, we're going to teleport player spawn point underscore entity. There we go. And we're going to open that in external editor. And what this is going to do, Control A, backspace, or actually Control Z, we're going to keep that. Let me just do the basic stuff. Backspace, enter, HC dots are going bye-bye. Boy, backspace the T, retype the T, click enter. Okay, so what this needs to do is it needs to register itself to the teleport player data. So if we go to our teleport player data, we need to have a list of spawn point gizmos. So I'm gonna hit Control-C, Control-V, change this to spawn points, change this to be spawn point gizmo, and now we've got an array of spawn point gizmos. We can then add this to our list of stuff. So spawn points is now in the bag of stuff. And then over here, we can go to pre-start and say pre-start, remove the void because I just don't care for them. And then we're going to type teleport player data dot spawn points dot push parentheses this dot entity dot as parentheses spawn point gizmo. Okay. Now we've added ourselves to that spawn point gizmo, and we can have one of these for every single player. And that's important because if multiple players are using the same spawn point, then they're going to get spawned in the same location, which is obviously what we're trying to avoid with this. Okay. So go ahead and clear. And so the next thing we want to do is create a spawn point that has this script. So gizmos, we'll go to spawn point gizmo. We're going to turn off spawn on start. We're going to change this to be at 0, 0, 0, so just completely out of the way. We're going to attach the script, teleport spawn point. There it is. Now this is ready to go, but we need one for every player in the world. So I just click on it, hit Control D, Control D, Control D. This is an 8-player world, so I need 9 of them. 1, 2, 3, 4, 5, 6, 7, 1, 2. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 9 because Horizon does occasionally accidentally let an additional player over the limit in. So always have one more than your world can actually support, just in case. And so now that we have our 9 spawn points, we can then head into our teleport player function and use that instead of player.position.set. So what we need to actually do is do a couple things. We need to know their spawn point. So we're going to say constant spawn point equals, and then we're going to do teleport player data dot spawn points item at index player dot index dot get. And so this gets the index of the player, which we hover over it, is a value between 0 and the max number of players in the world. And so this is going to get their specific spawn point from the list. Now, in the occasion that you forget to add enough spawn points, or maybe you increase the number of players in the world or something, we should use a question mark here to account for cases where this returns undefined. And instead, we'll return teleport data dot spawn points item at index 0. This is not an acceptable approach for dealing with, like, you could just have one spawn point and this script will work, but it will have those issues where 2 players are getting teleported on top of each other. So just like make sure to have enough spawn points. Okay, so now that a spawn point has been determined, we can now utilize that by moving it to the get best location. And so we're going to say spawn point dot position dot set to get best location, and then we'll run the parentheses 50 and then extra parenthesis there. Nice. And so now we've moved the spawn point to the position. The problem is if we try, I'm so sorry. I'm gonna need to go drink some water soon. I'm like just trying to help my throat. Okay. The problem is that if we try to teleport the player to that spawn point, it's going to go to the previous position. It's not going to go to where it's currently at. So we'll try that just to demonstrate it. So we'll say spawn point dot teleport. I really need to get water. I'm so sorry. I didn't set up water next to me today because I thought this was going to be a much shorter tutorial. It's going a little bit longer than I expected. But I hope there's a lot of detail that helps you out. And all that good stuff. So spawn point.teleport player parentheses, and then the player we want to teleport just to prove that it doesn't work. Control save. Okay. Also, noting that the player's index is probably based on the NPC gizmos too. So technically we would need additional spawn points for every gizmo then, or player NPC avatar that it arrives. So if I do console.log player.index.get, and then let's go Control X. We're going to move this into our teleport player entity. So when the player enters the world and we add them to the array, we're going to console log that just to prove that what I said is true. Control save. So this thing that it says here where it says it's a number between 0 and the max number of players in the world is no longer true because you have NPC avatars. Go ahead and hit clear. Go ahead and hit play. Yeah, 1, 2, 3, and 4. And then I'm player 0, jumping into preview mode. And as you can see, I've been spawned to 0, 0 because I didn't wait long enough for that spawn point to be teleported. So back in Typescript, we're going to delete the console log because we've determined that we need to have players, or we need to have spawn points in addition for each number of NPC in our world. And we also need to add a delay here. Now, the way that I add delay in my worlds is another script that you'll find in the utilities file. So we'll go ahead and get that right now. Reveal in File Explorer. And then I have this in my downloads. So if I go to downloads, there are two files. It's the utility component, utility entity, component entity. These two, utility component underscore entity and utility component underscore data. So Control C, back arrow, Control V. And so these utilities allow us to use async, which means we can use a delay in anywhere in any of our functions. And so we're going to need to attach a script to this. So we go to our scripts, bring out an empty object. We're going to call this the utility component manager. And then I'm going to attach that script to it. There it is. Okay, now that's set up. We're going to move this to 0, 0, 0. 0, 0, 0. We can then head back into Typescript. And then in our function, we can now delay the teleporting of the player by ½ a second. And so we'll say component utility data dot component dot async parentheses, and this is just a normal async, or excuse me, async dot set timeout. Then parentheses, and this is just a normal arrow function, just like we did before with our delay, comma. The delay here will be 500 milliseconds. I think that'll be enough. We might need to make it longer, but we'll try that first. Pressing enter here, we can then move spawn point.teleport player into that parenthesis, or those curly braces. Control save. And like that, we might be done. I think we are. I think it's that simple. It's a lot of things. The direction of the spawn point, rotating the direction of the spawn point might be something worth doing. Play. Jump into preview mode. All right, so we were teleported over here. Now we have line of sight to 2, which is unfortunate, but I do believe that's just bad luck. So we'll hit jump into preview mode again. And here we are teleported to a good location. Nice. So let's talk about rotation just real quick. So I think the easiest way to do this is to think about rotation relative to the player's current rotation. And if I'm not mistaken, on the spawn point gizmo, you can set it to be set position only so that it does not change the rotation of the player. And let's do that. Let's go ahead and delete all of these. And then we'll duplicate this one that's set position only. We're going to go ahead and click Control D. 2, 3, 4. There's the 4 for our players. And then 1, 2, 3, 4, 5, 6, 7, 8. Now we've got the 9 plus the 4. So that's the correct number for this world. And now we can head back into Typescript. I don't think there's anything we need to change here. Yeah, it's done. That was it. No Typescript, just adjusting the settings on the gizmo. Okay, jumping into preview mode. That takes care of our rotation. So we're always facing in the same rotation. So it's kind of hard to tell here, but whatever direction that is. Yeah, we're facing in the same direction as those players, so we'll jump into preview mode, rotate to the 90. Yep, and we're still facing the same direction. Very nice. Now we can still see players on that one. Let's see. How many of these come out looking at players? Wow, right next to him. Well, it's not ideal, but I guess it didn't have sightlines to those. I think this is really just the map not having enough hiding positions. Like if I go through here and just Control D, move this over, and move this over, right? Like we just start like hiding these people rather than putting them out in the open, and we create more areas for there to be, you know, this type of stuff. Probably see a much bigger improvement in the success of this. And over here, same thing. Control D, Control D. Yeah, I mean, right. Do that, Control D, slide that over here. I don't know, I feel like that's gonna do the trick. So stop, play, preview mode. All right, better. We'll try a few more of those. Still good. And still good, yeah. So the better your map is designed, the better overall this will work. But yeah, there you go. Now this does only work for top down. So there is one way to make this work for not top down, which was kind of a potential topic that we could talk about. So there's this thing called nav mesh. And so let's see. Oh, hello. Wrong one. I was going for this one. This one. That one. There it is. And so in Typescript, we could go into our teleport player data and create a Boolean, and we'll call this use nav mesh, and this will be set to true. And if we use nav mesh, this will allow us to do something very, very different than what we've currently been doing. And so what we're going to do is create a giant navigation volume. We also need to create an agent profile, which we'll just call player. The description doesn't matter. The height is 2 meters. The width is 0.25 meters. The slope, 45 is fine. Step height, 0.25 is fine. I press create. Okay, so now that we have a player profile, we can utilize that to determine where they can stand. We need to go to our gizmos and pull out a navigation volume. There it is. And then we're going to move this to 0, 0, 0. We're going to change the scale to match the grid. So 64, we'll go up by 15, 64. There we go. So we've surrounded the whole grid. We slide that up a little bit. So this fills the whole area. This is our navigation volume. It applies to all profiles, not just player. And now that we have this navigation volume, we can enable the NavMesh API. So go to APIs, NavMesh, turn on. I don't know if we need to do anything else. I think that's just it. So we'll hit apply. And we'll then clear. And we need to determine a location inside of this volume that we can go to. And so we need to have a reference to the nav mesh. So on our teleport player entity, we need to, in addition to the array, reference the nav mesh. So we'll type that in as nav mesh, control save. The teleport data will also need a nav mesh. So control C, control V. This is a nav mesh. There we go. And we'll change that to be nav mesh. And then we need to export that, so we'll call that nav mesh, comma, control save. And then on the teleport player entity, we can set that just like we did the array, control C, control V, change this to nav mesh, adjust for nav mesh as nav mesh. There we go. Now nav mesh says it's not assignable to player type entity. Okay, so I missed something. let's go look at the types. It's been a minute. I might need to go look at some of my old code to see how I did it in the past. We have navmesh path, we have navmesh profile, we have navmesh state, we have inavmesh, which I think is what I'm looking for because inavmesh gives us access to do get path and raycast. I don't think we need that. Get nearest point. This is what we actually want, is get nearest point, because it's going to allow us to get a position on the map, which will allow us to get inside positions. So the reason to do this is if you have buildings you can go inside of, the first method doesn't allow for that, but this get nearest point does allow for you to get a position inside of a building. So we have inavmesh as an interface. And if we look up inavmesh, we can see it's also used here. So we have get navmesh, which returns an inavmesh, and you get that from, what is this? This is running on, scroll to the top, an inavmesh agent, which I don't think we care about. Maybe we do. It's another interface. Let's go back down here. Navmesh agent extends entity. So maybe it's a navmesh agent. Let's see what it says. Represents an entity with locomotion and path finding capabilities. No, it's not that. How do we get an inavmesh? Command F inavmesh is from get navmesh, which is a property on things that can have a navmesh, but there's got to be a way to get it without that. So we're looking up this get navmesh because this is what we need access to. inavmesh here. This is coming from inavmesh agent. That's the interface. That's the same thing as we were just seeing, I think. Navmesh implements inavmesh. And that makes sense. Ah, here it is, get by name. This is what we want. So we have navmesh manager, default class navmesh manager, stores and retrieves navmesh references instances for use by Typescript scripts. Navmesh reference instances. Okay, this seems like something we can use. So we call navmesh manager dot get by name. Type in the name of player. Yeah, we type in, the word player. That's going to return the navmesh. This gets all the navmeshes, which we don't really need. We just need to get our specific navmesh. So, okie doke. So navmesh equals, we're not going to have a reference for it. We're going to say navmesh manager dot get by name. Let's see. Get by name is inside of navmesh manager. Why is that not here? Why is get by name not inside of navmesh manager? It says it is. Navmesh manager dot get by name. Why do you not allow that? I'm very perplexed by that. Navmesh manager. Not sure what this is happening. We'll delete that. And that. And actually, let's just delete all of that. And let's try that one more time. Navmesh manager, re-import. It's weird how it doesn't look like normal. I'm going to just make it look like normal. Curly braces. Why? Import navmesh manager from. I'm not sure why that's behaving differently than usual. Maybe let's delete this line and try again. Navmesh manager. Huh. Weird. Really, really weird. Default class navmesh manager. Let's see. Get instance world. Very peculiar. Not entirely sure I know what's happening on this. Class get by name is not available to us. We do have get nav meshes though, don't we? Dot. No, we have get instance. Get instance gets a nav mesh manager directory that stores the nav mesh reference instances. Oh, and it needs this dot world. Okay, so component utility data dot component dot world. Okay, we need to verify that I forgot we're inside of a component. We can just type this dot world. This dot world. There we go. Okay, so this is going to tell us that we're not getting the right thing because this is a nav mesh manager. So we've just gotten the nav mesh manager. Got it. Now we type dot. Now we have get by name, parentheses, and we know the name is player lowercase. Okay, so this could be undefined, and it says it could also be null. So we need to go back to our teleport player data and change this to be nav mesh is a nav mesh, undefined, or null. Okay, cool. Yay. Why are you unhappy still? Promise nav mesh or null is missing the following properties from nav mesh. Is it because I'm using a different version of nav mesh? Let's see. We go into the, we're getting nav mesh from nav mesh. That seems right. Different idea, same thing, but different. Control X, delete this from here. We won't even do this inside of here. Control save. Control save. We'll only do this in the data file because we can, and we'll say this equals nav mesh manager, which we'll need to import, and then we get instance, and then this is the component utility data.world. This doesn't work because it needs to happen after world start. Okay, well, anyway, we'll just pretend it does work. And then get by name, and I just want to force it to think that this works for a second. And it says the value of this is a promise. Is it because we're not in an async and we need to await? That was the problem. Command Z, Command Z. It was close. I was close. Small changes. Control Z, bring it back. We're in the wrong script. Control Z. Okay. This one, Control Z. Here we are. Okay, so we was just supposed to type await. That was it. And then we needed to type async here to allow it to await this because it's a promise. Apologies for the confusion. Got it sorted. Okay, now it's happy. Nav mesh has been assigned. Teleport data is happy. All good here. Okay, so now that we have the nav mesh, we can then go into our script here. We have get best location, which is getting grounded positions. And we were doing grounded positions a different way. So down here where we say get grounded position, we had getting a random position, and then we were using raycast. What we want to do is type if parentheses, and then we go into our teleport data dot use nav mesh. If we use nav mesh, we're going to do this slightly differently. So we'll then say curly braces. If we use nav mesh, we're doing it some other way. Else, we're doing it this way. And so we'll move this up into here. And so this is the old way. But if we want to use nav mesh, we're going to use the random position we got. And we need that y value to be on the ground, realistically. So the origin position should be different, but we'll be okay. So now what we're going to do is type constant, we'll call this closest position equals, and then if we call teleport player data dot navmesh dot get nearest point, we can find the nearest point to a position. So then we type random position, and then we need to give it a range. So the maximum range is going to be, I don't know, 300. That seems a little excessive. 100, 100? Sure. So it's got to be within 100 meters, but we're like, I'm going to go to 200. It shouldn't really matter, but because we're so far above the world, it'll work. It's just silly. So now closest position should be defined. And then what we want to do is say return closest position, question mark, or random position, So if for some reason this closest position is not valid, which there shouldn't be any reason, it will return the random position instead. Same sort of issue we did down here for those kind of weird cases. Okay, this is all set up to work. So I believe everything here is finished. I'm going to leave the data file open so we can change that back to, we're going to use navmesh as kind of a last result. Yeah, that's just kind of another way to do it. But now we're going to go ahead and hit play. Going to jump into preview mode, and I think it went 0, 0, 0. Let's try that again. Jump into preview mode. Oh, that's not working. How interesting. How very, very interesting. Something's gone wrong somewhere along the lines. Let's find out why. Okay. Go to teleport player function. And we could track down where this is happening, but it's most likely happening right where we wrote this code here. So we have use navmesh. So we're going to just do console.log. When I'm counting things, this is like step 1. And then step 2 is the closest position. So we'll say console.log or 2, and then colon space, and then plus closest position, dot to string, sure, sure, that should be fine, control save. Because I think this is going to return null or undefined. So for some reason, it's not getting a position back. And we're going to have to figure out why in a second. Okay. Jump into preview mode. Yeah, it's returned undefined every single time. A lot of times. A very, very large number of times. So something's gone wrong with our navmesh. And we're just going to have to keep investigating to figure out what has gone wrong. So we know for sure that 1 is happening, so we can delete that. This is the new 1. We want to get closest position to return a valid value. But we're not sure if the navmesh is the problem. Like, is navmesh not defined? Like, did I not name it correctly? If we go into navigation, we have profile player, so that seems correct. Double check that I named it player on the teleport player entity. I did. So get by name says get a reference to a navmesh reference instance based on a profile name. So yeah, player should have been returned. If no matching profile is returned, it returns null. So I have a feeling this is returning null. Let's move this down to the bottom so that it's happening after all the non-async stuff. So it happens before, or it happens at the end. That makes sense. I don't think that'll change anything though. That's just like better practice. Get a navmesh manager directory that stores the navmesh references in this .world. Yeah, that seems right. Everything seems good here. Then so I'm pretty confident that if we go and say teleport player data dot the navmesh, this I believe is null. So hopefully that's going to return and tell us what it is. So if it returns undefined, then the value was never set. If it returns null, then the value couldn't be found. And if it returns something else, well, that'll be very curious. All right, it returned an object. Okay, so it is defined. That's surprising. That is very, very surprising. Okay, so the nav mesh is defined, so the get nearest point is the problem. So we passed in the random position. The range must not be allowed to be that big. So let's take, let's raycast down and do this for both of them. Alt arrow up. So for both of these, we're going to raycast down, and then we're going to get the nearest point to the grounded position. Control C, Control V. And then we're going to check within, we'll say 50 meters of that. And we'll go back to console logging the closest position. And I think we can move the Y value up here as well. That can be done right there. Yeah, so else we return grounded position. Otherwise, we're calculating a nav mesh position. So far, so good. Very curious if that will solve our problem. Kind of perplexed right now still. Hopefully we'll, maybe I have to leave and come back. I wonder if that wouldn't be a surprise. Jump into preview mode. Okay, it's still returning undefined, and so it teleported me into the sky to one of the random positions. Still returning undefined. And we know that undefined, how could undefined happen? Let's check that. So if closest position is undefined, that is because this returns null. So undefined is because nav mesh is undefined. What? What? I thought we just determined that nav mesh was not undefined. Well, let's try this one more time. Control C. Nav mesh, does it have a .toString property? It does not have a .toString property. So it should basically return as an object. It should say object, object, which is what it said. Otherwise, this will say null or undefined. Huh. Very, very curious why that seems to be giving us mixed signals. Clear. 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 I really should just leave and come back. The chances that that are the bug at this point seem very high. Jump into preview mode. Yeah, that says it's an object. So that should have worked. Question is, why are we spawning in the air? Return closest position, if not, return random position. Oh, okay. Was that not working in the past? Because it wasn't teleporting us earlier. What changes? I moved this out. We changed closest position to use grounded position. That's curious, to say the least. That is very curious. Get nearest point. Should be returning the nearest point. The nearest vector 3 available within the range, or null if no point is found. And we know it's not returning null. Nav mesh. Closest position should be a vector 3. Why is it not? Why is it not? Okay, let's leave and come back. Return to creation home, leave. I don't get it. Perplexed. Very, very, very perplexed. Hello again. Okay, this is definitely getting to be way longer than I intended it to be. So apologies, where I think I just hit the 2-hour mark. Oof. Yeah, 1 hour, 59 minutes, and 58 seconds. Yeah, apologies for the length of this. I was really hoping to do this one in like half an hour. For some reason, I was like, yeah, this is easy. This won't take very long. And I'll throw in a bunch of extra stuff, like this whole topic on NavMesh. Mostly because I have a world I'm going to be working on that will have... Oh my gosh, I just realized the problem. I was like going to explain this thing about how this world's going to have indoor spaces, and like this is something I'm going to use on one world and I'm going to use the other version on a different world, so like both are super applicable. Okay, it was such a dumb mistake. So I don't know who was screaming at their computer screen, bake your mesh, but yeah, I forgot to bake the nav mesh. And if you don't bake the nav mesh, it just doesn't work. So everything was correct, just the nav mesh wasn't baked. So you have to go in and hit navigation and then hit the wrench icon, which bakes it. And now when I jump into preview mode, it'll just work. Hey, look at that, it works. I'm next to a player, that's dumb, but otherwise, totally working. Jump into preview mode. Okay, so now nav mesh is working correctly. Darn it. Darn it. Why? That's so crazy. What I want to know... Oh, wrong one. What I want to know is the closest position. Is it off the ground? Like, do they automatically move that off the ground for us? So we're going to check that by logging it to the console. And the second question was, maybe we should be baking this every time, just in case the map is changing or you got like moving elements, or you forget to do like what I just did. So we say teleport player data dot navmesh dot rebake, and that should rebake the nav mesh. I don't know how intense this is. I really don't. Please let me know in the comments if you know how intense rebaking the nav mesh is. And like maybe we shouldn't be doing that every time we teleport a player. Or maybe we can and it's not a big deal at all. Like the raycast ended up not being a big deal. I'm not really sure. So we'll go ahead and wait for that. Go ahead and hit play. I'm worried about larger, like more complex meshes. Like with cubes, I'm not as worried, but with larger worlds, I'm a lot more worried. Okay, here we are, placed nicely. Checking the console, we can see the positions are at ground level. So we're going to need to move these above ground level. So we need to move them up by 0 or by 1. So we say closest position has been determined. We then want to say if parentheses closest position. And you know what I'm actually going to do? I'm just going to do the same thing we did before, which is closest position dot y plus equals 1, and then add the question mark here, question mark, random position, random position, and then we can remove this question mark here, and that's going to move it up. We don't need this console log anymore, so we're moving the y up by 1 value, which will then return that. Definitely has me questioning having 2 returns plus this double plus 1. Does that really matter? Not really sure. But what I wanted to demonstrate, the real reason that we created this was for indoor spaces to work. And so we need to create some indoor spaces. Now you'll need to make sure that the roof, if you don't want the roof to be accessible, the way that this is working with the raycast would make it choose the roof. So you'll need to change your nav mesh. Why isn't it letting me change the volume? Navigation volume, adjust to 7, so that the roof isn't included as a walkable space, right? And so if I select all these cubes, I guess there's not all of them, but we'll just change this navigation volume to be 4, move it down to 1.5. There we go. So that's focusing on the ground, and then we can add a layer on top of this. So we'll Control D this cube, and then we'll just turn that into 0.1, 0.1, 0.1, change this to 0.01, and then move that up. All right, so now we got a roof, sort of. We'll keep making it better in a second. Change that to 0.5 and 0.5, nice. And then move that to 0, 0, 0. And then we made this 3 high, so if I go to 3 high, that should put it on top, nice. All right, so now we got a roof, and we got the nav mesh volume specifically excluding going to the roof. So now, theoretically, I hit play, it's going to rebake it for me in the script, so I didn't have to hit rebake. I can then hit enter preview mode, and it's going to teleport me inside, which was not possible with the previous one. So if we were to stop the world, go into our script, and change the teleport data to use the raycast, making this false, Control Save, it will then teleport us onto the roof, because it only does top down. So Nav Mesh adds this ability to go inside of volumes, which is super duper cool. Play, jump into preview mode, and we're on the roof. Yeah, so pretty sweet, if I do say so myself. We'll go ahead and turn that back to true. Maybe not true. We'll set it to false. So there's a lot of setup to make all of this scripts work, but hopefully this helps. I will have the scripts in the thing. I'm going to go drop those in right now. Man, that was a big one. That was a big one. Whew. So jump into the description. You're going to find those files. Is that in my drive? Maybe it's in, oh, I'm in the wrong drive. Let's go to business drive. Get me signed in. And seriously? 2-step verification, always catching me. Come on. Yes, it's me, you silly computer. All right, Vidyuu Assets, there we are. And we need to create a new folder for this. And today's date is 2024. Last day or two of 2024. Happy New Year, you guys. Dash 12th month. Dash 30th day, and this is the teleport, call this the random random teleporting. All right, folder created. I am going to zip these files up. I think that's going to be the way to go. I think I could just drop them in there. Google will unzip them for you. Yeah, so we'll just, I don't know. I had one guy this past week who just was like really upset with the number of scripts, and I'm just like, they're kind of small scripts. Like if you look at them, they're not that bad. Like, I guess, I don't know, there's some depth to them, but they're not that bad. And these are utilities, so I don't know, it's not too bad. Right click, reveal in File Explorer, there we are. Selecting all the scripts, Control, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Got our 8 scripts. I just need to drag and drop that into Chrome. Drag and drop. All right, there you go. As of immediately before the video is even uploaded, you have access to these files. So if you're watching this, feel free to go download them. I do think it is better to write it on your own. So using these as a reference is going to help you learn the content better. You know, typing, I believe, builds muscle memory. Anyway, it's my personal recommendation. And but you can just go download it and implement it if you would like, and that's a-okay by me. All right, guys, I really appreciate you tuning in for this overly long. Apologies, that was overly long, but I really appreciate you guys tuning in, and I will catch you in the new year. Bye.